So hi children, how are you all? I hope all you fine. So children, say that next concept here, that is concept 5. So this is related to relation between roots and coefficients. So children, when I explained you in that worksheet 3 problems, there we used that some conditions in that nature of the roots. We explained about that a plus b plus c is equal to 0. Then the roots of the quadratic equation c by a as well as 1. Okay, that conditions we used in that worksheet 3, no? So that is related to relation between roots and coefficients of a quadratic equation. Okay, so here briefly we will learn about that. Okay, so let us say that for the equation, for the quadratic equation ax square plus bx plus c is equal to 0. For ax square plus bx plus c is equal to 0, if alpha comma beta are the roots, then we know this condition, that if the quadratic equation ax square plus bx plus c is equal to 0, if the roots are alpha and beta, then alpha plus beta is equal to minus b by a. And in the same way, alpha beta is equal to c by a. This condition we know that, right? So depends on this condition we will learn about that relation between roots and coefficients. Understand? So here say that the first condition, that is if a plus b plus c is equal to 0, okay, of the quadratic equation ax square plus bx plus c is equal to 0. Okay, if a plus b plus c is equal to 0 for the quadratic equation ax square plus bx plus c is equal to 0, then the roots are 1 and c by a. 1 and c by a. So this is the first condition. What is that? If a plus b plus c is equal to 0 for the quadratic equation ax square plus bx plus c is equal to 0, then the roots are 1 and c by a. So what is the proof? Okay, so let us see the proof. Okay, once again I am writing, say that if a plus b plus c is equal to 0 for the quadratic equation ax square plus bx plus c is equal to 0, okay, then the roots are 1 and c by a. Okay, here see the proof. So children, say that if given quadratic equation, what is the given quadratic equation here? That is ax square plus bx plus c is equal to 0. Okay, this is the given quadratic equation. So here if you take that, if x is equal to 1, then substitute that x is equal to 1, then a into 1 square plus b into 1 plus c is equal to 0. So from this one, this is equals to a plus b plus c is equal to 0. So that condition satisfying here or not? A plus b plus c is equal to 0, a plus b plus c is equal to 0. When it is possible? If that x is equal to 1, then one of the root alpha is equal to 1. One of the root alpha is equal to 1. Now here we know the condition sum of the roots. Okay, so sum of the roots is equal to, what is the formula? Sum of the roots is equal to alpha plus beta, which is equals to minus b by a. Okay, and in the same way product of the roots, so product of the roots is equal to c by a. Product of the roots is equal to c by a. Okay, so here c by a is equal to, here we need to find out that, okay, which is equals to alpha into beta. Clear? So see that ma. So if you take that second condition, product of the roots, already we know that if alpha is equal to 1, the first root is alpha is equal to 1, then alpha beta is equal to C by A here given, no? So which is equals to 1 into beta is equal to C by A. Therefore beta is equal to C by A. So what is the second root ma here? That is C by A. So that condition here they given, if one of the root is 1, another root is C by A. Okay, this condition is applicable for that. If A plus B plus C is equal to 0 of the quadratic equation, ax square plus bx plus c is equal to 0, then that quadratic equation is having that roots are 1 and C by A. So this is the proof. Understand? So this is the first condition. Now we will learn about the second condition. Okay, sure then. So let us see that next concept 5, here second formula. Okay, already we discussed that first one. No? So second one here, the point is, if A minus B plus C is equal to 0. What is the condition? If A minus B plus C is equal to 0 of the equation, then the quadratic equation ax square plus bx plus c is equal to 0 has the roots minus 1 and in the same way minus C by A. So why? Because here the roots are minus 1 and minus C by A. So here the reason is, if you substitute that here x is equal to minus 1, okay, then we can write this one as x plus 1 is equal to 0. Then we can say that x minus 1 is equal to minus 1. We know that, right? So here x is equal to minus 1. So if you substitute that x is equal to minus 1 in the quadratic equation, ax square plus bx plus c is equal to 0. So substitute that x is equal to minus 1 here. So a into minus 1 whole square plus b into minus 1 plus c is equal to 0. Am I clear to you? So substitute this one here. So minus 1 whole square. So minus 1 whole square is always positive, we know that, right? So 1 into a is equal to, again that is a, and here minus into plus is minus. So b into 1 is equal to b, and in the same way plus c is equal to 0. So here the condition is a minus b plus c is equal to 0. So when it satisfies here, if x is equal to minus 1, so one of the root is minus 1. So let us see that the next one here, what about that minus c by a? So see here second proof, that is when we will get that minus c by a here. So if you take here ax square plus bx plus c is equal to 0. So already we got clarity about that, one of the root is minus 1. So alpha is equal to minus 1, and we know that this equation is having the two roots, right? So those two roots are alpha is equal to minus 1, and we can take that another root, that is beta. So we need to find that beta, right? So for finding that, here sum of the roots, so sum of the roots is equal to minus b by a, as well as here product of the roots alpha beta is equal to c by a. Okay, so here alpha value we know that, right? What is that alpha value here? That is minus 1. So substitute that alpha is equal to minus 1 from that product of the roots. So alpha beta is equal to c by a. So here substitute that minus 1 into beta, which is equal to c by a. Clear? So minus 1 into beta, which is equals to minus beta, is equal to c by a. So from this one, here beta is equal to minus transforms to that RHS side, so which is equals to minus c by a. So from this one here we can say that beta is equal to minus c by a, and here alpha is equal to minus 1. So children, did you understand this? So here if a minus b plus c is equal to 0 of the quadratic equation ax square plus bx plus c is equal to 0. Okay, so when it satisfies this condition, means if x is equal to minus 1, okay, then only this condition satisfies. So x is equal to minus 1 means that is one of the root, right? So if you substitute that x is equal to 1 means that is one of the root, alpha is equal to minus 1. So if you substitute that one in that product of the roots, so alpha beta is equal to c by a. So if you substitute here minus 1, then we will get that minus beta value. So we need to find that positive beta value, right? So that's why transforms that minus into that RHS side. So then we will get that beta is equal to minus c by a. Am I clear? So that's why here the roots are minus 1 and minus c by a. Clear? Yes. So let us see that the next point here, if difference of the roots, is 1. Okay, if the difference of the roots means 1 means here, if you take that the roots are consecutive roots, for example, 2 and 3 are the roots of the given some quadratic equation. Okay, so 2 and 3 are the roots. So these two are the two distinct roots, as well as the difference between 2 and 3 is 1. So at that cases the delta value is equals to a square. At that cases the delta value is a square. So one example I will show you that. See, for example here, alpha is equal to 2 and beta is equal to 3. Two consecutive roots are there. Okay, 2 and 3. So here just observe that what is the quadratic equation by using that roots. So here we know that if we know that roots of the equation, then we can find that quadratic equation, right? So see here. So alpha is equal to 2, beta is equal to 3, x square minus of alpha plus beta into x plus alpha beta is equal to 0. Clear? So from this one here, x square minus alpha is equal to 2 plus beta is equal to 3 into x plus 2 into 3, which is equals to 0. Clear? So from this one, x square minus 2 plus 3 is 5x plus 2 3 6 is equal to 0. So by using these two roots, here we got that x square minus 5x plus 6 is equal to 0. Okay, so here what they are saying, if that the difference of the roots is, so we can take anything, right? So difference of the roots, beta minus alpha is equal to 3 minus 2 is equal to 1. So that condition is satisfying or not, see here. So delta value a square they are saying. So delta means here discriminant, that is b square minus 4ac. So this value they are saying a square. So a square means from that quadratic equation. Okay, so first see here, b is equal to, so from this quadratic equation here a is equal to 1, b is equal to minus 5, c is equal to 6 and c is equal to 6. Okay, so from this one here, b is equal to minus 5 whole square minus 4 into here a is equal to 1 and in the same way c is equal to 6. Okay, so see here, minus 5 whole square, so minus 5 whole square is 25 and here minus 4 6 24. So 25 minus 24, which is equals to 1. Am I clear to you? So here if the difference between these two roots is 1, then here they are saying delta is equal to a square. Okay, so from this one here a is equal to, what is the value of a here? 1. So 1 square is again 1 only. So here delta value is equal to a square only, no? Is it satisfying or not? Okay, so this is the next point, third point. What is the third point? If the difference between the roots of a quadratic equation is 1, then its discriminant value is always equals to a square. So a square means from that given quadratic equation, here we have to find that ABC values, right? So from that one a square value is equal to the discriminant. So at that conditions, why madam here we have to use this type of conditions, means simply without doing this much process, directly we can go for that answer. Okay, so just to say that, first we have to observe that the difference of the roots. If the difference of the roots is equal to 1, when we can say that difference of the roots is 1? If those two roots are consecutive roots, then only we can say that the difference between those two roots are 1. At that cases, okay, simply we can go for that delta value, that is always equals to, just we have to observe that quadratic equation. From that a square value is the value of discriminant. Okay, so this is the third point. So children, after that, so next say that fourth point, this is related to ratio. So up to now we discussed about that single values, alpha value and beta value, and in the same way it's a difference also we have seen, right? So now here we are going to discuss about that the roots and its ratios. Okay, so if the roots are in the ratio, if the roots of a quadratic equation are in the ratio m is to n, are in the ratio m is to n, then the condition is, So here if the roots of a quadratic equation are in the ratio m is to n, then m plus n whole square into AC, which is equals to mn b square. So this is the condition. What is that condition here? If that roots of a quadratic equation are in the ratio m is to n, whatever it may be its ratio, okay, that ratio is m is to n, okay, at that cases the condition is simply ratio, roots ratio the given means by using this one we can find that equation, okay, and we can find that condition here, okay. So what is that condition here? M plus n whole square into AC is equal to m and b square. So this is the condition. So let us see that proof, how we got this condition, okay. So see here. Okay, so see here, given that let roots are m alpha and n alpha. Why madam here we taken that m alpha and n alpha? Why? Because see here roots are in the ratio m is to n. Okay, so given roots are in the ratio m is to n means when we can say that m is to n? If that root value is same, okay, so if you cancel that alpha and alpha, then we will get that m is to n ratio. So we are talking about that one only, no? Okay, so if that roots are in the ratio m is to n, so these are the roots what we taken here, m alpha, n alpha. So if you cancel that alpha and alpha, we are getting here m is to n. So first one satisfying here. So these two roots are in the ratio m is to n. Okay, we have clarity. Now here let the quadratic equation ax square plus bx plus c is equal to 0. So this is the required quadratic equation, general form of the quadratic equation here we taken. Now here sum of the roots. So m alpha plus n alpha, sum of the roots is equal to minus b by a. Yes? Yes. See here. So from these two here, from these two terms here we can take that alpha as common. So from this one, alpha into m plus n is equal to minus b by a. Okay, did you get clarity about this? Yes. So see here, from this one, m plus n, sum of the roots value we are finding here, right? So m plus n is equal to minus b by a into, here alpha is there, no? So that one becomes here division, so a into alpha. Okay, so this is the first condition here what we got. Next we need to find that product of the roots. So product of the roots means here m alpha into n alpha. So product of the roots we need to find out. So m alpha into n alpha is equal to c by a. Is equal to c by a. So from this one here mn into alpha square, which is equals to c by a. Okay. So from this one, just observe that here we got that m plus n is equal to minus b by a alpha. So from this one only we can write another formula. What is that? Alpha is equals to minus b by, here already a is there, no? So a into m plus n. We can write this one also, no, from this condition. Okay, so here alpha value, alpha is equal to minus b by a into m plus n. Why? Because I written that one means, here just observe that here mn value we got, previous we got that m plus n value, so alpha is common, right? So substitute that alpha value here. Okay, so alpha square is equal to c by a into mn. Clear? Now we have that alpha value. What is that? Minus b by a into m plus n. Minus b by a into m plus n whole square is equal to c by mn into a. Clear? So just to simplify it, so minus b whole square is b square by a square into m plus n whole square, which is equals to c by mn into a. Okay, so from this one, yes, so here a and a one time here gets cancelled. So from this one, b square by a into m plus n whole square, which is equals to c by mn. Okay, so these are the leftover terms. So from this one here, just take that cross multiplication, then we will get that b square into mn, b square into mn, which is equals to c into here a into m plus n whole square. Okay, so from this one mn into b square, which is equals to a into c is ac into m plus n whole square, or m plus n whole square into ac. Just I am changing the terms, which is equals to m and b square. So this is the required condition. So from this way we got that this is the condition when we are having that roots are in the ratio m is to n. Okay, so at that cases m is to n means directly we can use this formula. For example, if the roots are in the ratio 1 is to k, 1 is to k, which means here one of the root is k times of the other root. Understand? One of the root is k times of the other root. At that cases here we can use these conditions. And in the same way, one of the root is 2 times of the another root. Okay, another example, one of the root is 3 times of the another root. So at that cases, what are the ratios here? If that the roots are in the ratio 1 is to k, which means one of the root is k times of the other. Okay, and one of the root ratio is 1 is to 2, which means here one of the root is 2 times of the other. And in the same way, another example, for example, roots are in the ratio 1 is to 3. At that cases, one of the ratio is 3 times of the other. Okay, so in that cases, at that purpose, here we have to use the condition is m plus n whole square into ac is equal to m and b square. So I will show you that some examples here. Say that. ఇది మధ్యలో ఉంది.
అయిపోయాక చెప్పండి, అయితే ఇచ్చేస్తాను ఒక వర్క్ షీట్ అయితే.
Okay. So see here ma, one of the point, if one of the root is k times the other, one of the root is k times the other. So at that cases, what is the ratio here? So number of times given means here we can write that ratio. So one of the root is k times means this is in the ratio 1 is to k. This is in the ratio 1 is to k. So at that cases, what is the formula here? Just simply substitute that 1 and k at the place of m and n. So what is the formula for that if the given roots are in the ratio m is to n? So what is the condition? What we discussed here, that is m plus n whole square into ac, which is equals to m and b square, which is equals to m and b square. So by using this condition here, m is to n, here 1 is to k. So just simply substitute that values here. So at the place of just compare this with m is to n. So m is equal to 1. So here m is equal to 1. So we can write that one as 1 plus k whole square into AC. So AC means that is related to A and C. Those two letters, those two terms related to equation. Okay, so no need to change that. Just change m and n values only. Okay, so which is equals to m into n. So 1 into k b square. B is also related to equation. So that's why no need to change that. So from this one, 1 plus k whole square AC is equal to 1 into k is k b square. So this is the condition. Okay, and in the same way, just I'll tell you one example. If that roots are in the ratio 1 is to 2, at that cases, just simply comparing with m is to n. So simply write that 1 plus 2 whole square. AC values we need to substitute from that given quadratic equation. And here mn, if that quadratic equation not given means roots already they given, right? So like this m is to n condition, roots ratio given means must and should they will give that quadratic equation. So that's why easily we can find that ABC values. Easily we can write from that given quadratic equation. Okay, when they will not give quadratic equation means if they will give that directly given roots, if they will give the directly roots, at that cases okay we have to find that equation. but this kind of questions directly they will give that equation. Okay, so 1 plus 2 whole square into AC is equal to 1 into 2 and here b square. So 1 plus 2 is 3 whole square, AC is equal to 1 into 2, so which is 2b square. So 3 square is 9, so 9 AC is equal to 2b square. Clear? So this is the condition. Just substitute that AC values, then we will get that B value. At that cases, any one of the letter value they will miss that. So we have to find that value. Okay. So simply the questions are in like that. If that roots are in the ratio 1:2. Okay. Then the quadratic equation ax square plus kx plus c is equal to 0. At that cases, find the value of k. Find the value of k. In that situations we have to use these conditions. Okay, so this is the next fourth condition. After this we are having one more condition. What is that? See here. If one root is negative of other, if one root is negative of other, okay, so this is a condition. What is that? If one root is negative of the other, at that cases what changes will happen means, at that cases then b is equal to 0. Okay, this is the condition. What is that? So for this kind of questions, for example, alpha and minus alpha are the roots of the given quadratic equation ax square plus kx plus c is equal to 0, then what is the value of k? So simply, without simplifying that, simply k value is 0. K value is 0. How you got that b is equal to 0? Just see here. What they are saying in that question. See, in that condition actually what they are saying here, two roots are negative of each other. Two roots are negative of each other means two roots are equal but different in its magnitude. Okay, two roots are equal roots. Two roots are equal, but those two are differ in their magnitude. Differ in their magnitude, which means here one is positive alpha, another one is minus alpha. Okay, so having that different signs. So for example 2 and minus 2. So 2 and 2 are equal, but there is a change in its symbols. Okay, one is positive, another one is negative. Okay, so that's why here this type of roots, for this kind of roots they are saying always b value is 0. So let us see that. If alpha and minus alpha are the roots, so of the quadratic equation, what is the general form of a quadratic equation here? That is ax square plus bx plus c is equal to 0. Okay, so at this kind, just take that as sum of the roots. So alpha plus of minus alpha, sum of the roots, which is equals to minus b by a. And in the same way, alpha into minus alpha is equal to c by a. This is product of the roots. Okay, here no need to go for that product of the roots. Why? Because here we will get that minus alpha square, which is equal to c by a. So if you know that alpha value, then easily we can find that c by a. Okay, either c or a value we can find that. So just to say that here condition related to b. So that's why take this one. So alpha plus into minus, which is equal to minus alpha. Alpha plus into minus, which is equal to minus alpha. So which is equals to minus b by a. Clear? So alpha and minus alpha gets cancelled. So from this one here minus b by a is equal to 0. Okay. So for example 1 and minus 1 are the roots. So plus 1 and minus 1 gets cancelled. So that is 0. So minus b by a is equal to 0. So here minus b is equal to 0 into a. So which is equal to 0. Next minus b is equal to 0. From this b is equal to 0. Hence it is proved. Am I clear to you? So if one root is negative of other, then b is equal to 0. Clear? So for example say that here the quadratic equation is ax square plus k something 2x square plus kx plus 3 is equal to 0. Let one example. Okay, see here 2x square plus kx plus 3 is equal to 0. Here the roots are, for example, minus 1 and 1. Roots are minus 1 and 1. So what is the value of k here? So what is the value of k? So at that cases k is equal to 0. Simply k is equal to 0. Okay, if you substitute that, then we will get that answer. So just to see that, if you take that one as example, 2x square plus kx plus 3 is equal to 0. So roots are alpha is equal to 1, beta is equal to minus 1. Okay, so let us take here sum of the roots ma. So alpha plus beta is equal to 1 plus of minus 1 is equal to minus b by a. So minus k by 2. Clear? So plus 1 and minus 1 gets cancelled. So 0 is equal to minus k by 2. So from this minus k is equal to 0 into 2 is equal to 0. So from this one k is equal to 0. Clear? So by this way here no need to find this much of, no need to use that this much of time here. So that's why simply we can go for that answer. At that cases one of the root is, those two roots are same but their symbols are different, but their magnitudes are different, which means one is positive, another one is negative. Okay, so at that cases only here directly we can write the answer as b is equal to 0. Okay, so this is that next condition. So let us see that another condition. See here, if one root is reciprocal of the other, what is the next condition? If one root is reciprocal of the other. Okay, one root is reciprocal of the other. At that cases, what is the condition? A value always equals to C. Then A value is always equals to C. Okay, one C here. So let the roots are alpha and 1 by alpha. Yes or no? That one only know meaning of the question. See here, meaning of that sentence, what is that? If one root is reciprocal of the other, which means these two roots are reciprocal to each other. Okay, 1 by alpha is the reciprocal of alpha and alpha is the reciprocal of 1 by alpha. So we can say that here roots are reciprocal to each other. At that cases, here the condition is A is equal to C. Let us say that. So let us take that quadratic equation ax square plus bx plus c is equal to 0. So sum of the roots means alpha plus 1 by alpha is equal to, what is that, minus b by a. Okay, if you know that alpha value, if they will give that alpha value in that question, no, so directly you can substitute here, then we can find that either b value or a value, that is depends on the question. Okay, now come to that here, product of the roots. Alpha into 1 by alpha is equal to c by a. Here the given the condition related to c and a. Okay, so here just observe that alpha and alpha gets cancelled. Okay, the product of two reciprocal values is always equals to 1. Okay, we know that, right? 2 into 1 by 2, 3 into 1 by 3, 4 into 1 by 4 is always equals to 1. Okay, so any value, its reciprocal, its product is always equals to 1. Okay, by using that condition here, 1 is equal to c by a. So from this one, c is equal to 1 into a is equal to a. So from this, c is equal to a or a is equal to c. Am I clear to you? So what is that condition? Once again, see, if one root is reciprocal of the other, then a is equal to c. Clear? Yes. So this is the next point, and still we are having one more condition is there. Just to say that what is the condition? So let us see that next point. What is that? If one root is square of the other, if one root is square of the other, then what is the condition? Here the condition is a plus c into ac plus b cube is equal to 3abc. What is the condition? If one root is square of the other, one root is square of the other, then a plus c into ac plus b cube is equal to 3abc. Okay, so see here. So what is the proof? How we got that condition? See here what they are saying, one root is square of the other. So let the roots are alpha and alpha square. Let the roots are alpha and alpha square. Now the quadratic equation ax square plus bx plus c is equal to 0. This is the quadratic equation, right? So here just say that let the roots are alpha and alpha square. So sum of the roots alpha plus alpha square is equal to minus b by a. Minus b by a. And in the same way here, product of the roots alpha into alpha square is equal to c by a. Alpha into alpha square is equal to c by a. So just observe that here children. So if you take in that alpha as common, then 1 plus alpha is that left over. So which is equals to minus b by a. Okay, so come to this one here. Alpha into alpha square is equal to alpha cube is equal to c by a. Alpha cube is equal to c by a. So here directly you can use like this, or else to this one also you can apply that. Okay, so see here. So directly we will apply to this one. So let us take this one as a first equation. So from this one here, alpha is equal to c by a whole power 1 by 3. Shall we write like this? Alpha cube is equal to c by a. So alpha is equal to c by a whole power 1 by 3. Now we got that alpha value, right? So just directly substitute here alpha value. Okay. Now substitute alpha is equal to c by a whole power 1 by 3 in the equation 1. In equation 1. So equation 1 what we got here? That is alpha plus alpha square is equal to alpha plus alpha square is equal to minus b by a. So substitute that alpha value here. So c by a whole power 1 by 3 plus here alpha value, what is that? C by a whole square is there, no? So 2 into 1 by 3 is 2 by 3. Okay, so which is equals to minus b by a. Am I clear? So to this one, just apply that cubing on both sides. What we have to do here? That is cubing on both sides. Okay, so let us take that cubes here. C by a whole power 1 by 3 plus c by a whole power 2 by 3 whole cube, which is equals to minus b by a whole cube. Clear ma? So here x power 1 by 3 plus x power 2 by 3, which means here a plus b whole cube formula is there. So a plus b whole cube formula, what is that? A plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. Okay, or else a cube plus 3ab into a plus b cube also we can write. Okay, so by using this formula here, a plus b whole cube. So a is equal to c by a. So a cube 1 by 3 whole cube. A cube plus b cube, which means c by a whole power 2 by 3 whole cube. So a cube plus b cube plus 3 into a into b. So c by a whole power 1 by 3 into c by a whole power 2 by 3 into a plus b. So a is equal to here c by a whole power 1 by 3 plus c by a whole power 2 by 3. Clear to you? Just observe once again here. a cube plus b cube plus 3ab into a plus b. Clear? Now see here, 3 and 3 gets cancelled. Here 3 and 3 gets cancelled. Okay, is there any other? No, that's it. So see here, leftover c by a, 3 and 3 cancel, so that's why that is c by a. C by a. Okay, plus again 3 cancel, so c by a whole square plus c by a whole square. Okay, plus here see that 3 into c by a whole power 1 by 3 and here also c by a whole power 2 by 3. So these two are in the form of a power m into a power n is equal to a power n plus n formula is there, no, in that exponents. Okay, so use that formula here. Okay, so see here what we will get here. So plus 3 into c by a whole power 1 by 3 plus 2 by 3 into, here what we got, ma? Actually here we have to write that minus b cube by a cube. Okay, is equal to RHS also there, no? So that's why that one we have to write there. Now into a plus b. Here a plus b value already we know that what is that, a plus b is equal to minus b by a. So we can substitute that at the place of a plus b, we can substitute minus b by a. Okay, so that's why into minus b by a, which is equals to minus b cube by a cube. So that is RHS, no? That is. Now simplify it. So c by a plus c by a whole square plus 3 into, here c by a whole power, here 3 and 3 is common and 1 plus 2 is 3 into minus b by a, which is equals to minus b cube by a cube. Clear? So from this one, c by a plus c square by a square, just to simplify it. So 3 and 3 gets cancelled, plus 3 into c by a into minus b by a, which is equals to minus b cube by a cube. Clear to you? So next, so c by a plus c square by a square, and here minus into plus is minus, and here b into c is bc, so which is equals to minus 3bc by a into a is a square, which is equals to minus b cube by a cube. Okay, now simplify it. Okay, so these three also having that, here c by a is there, c square by a square, and here 3bc by a square. So we can take that LCM, that is a and a square, that LCM is always equals to a square only, no? So that's why, what is the LCM here? The LCM is a square. So the leftover terms, here a only one time is there, so we have to multiply with another time. So a into c, that is AC, and here a square is there, so plus c square minus, and here a square is there, so that is minus 3bc, and here which is equals to minus b cube by a cube. So see here 2 times there, here 3 times there, so still here one more time is there. Okay, here 2 times a is there, here 3 times a is there, so 2 times gets cancelled, so still left over here 1 time is there. Okay, so from this one, AC plus c square minus 3bc, which is equals to minus b cube by a. Okay, now multiply with LHS, which is equals to a into AC, which is equals to a square c, plus c square into a, that is ac square, minus 3bc into a, 3abc, which is equals to minus b cube. Clear? So from this one, from that first 2 terms, here take that ac as common. Take that ac as common. So left over here, 2 times a is there, we taken 1 time as common, so that's why still left over here a is there. Plus here c 2 times there, a already we taken as out, no, so no need to write that. So from that 2 times here we taken 1 time, so left over here 1 time, a plus c, minus 3abc is equal to minus b cube. Okay, so see here from this one, a plus c into ac. Okay, and here minus b cube is there, no? So take just transform into that LHS side, we will get that one as a plus b cube. Plus b cube, which is equals to minus 3abc become as plus 3abc. That's it. This is the condition what we got here. See here, a plus c into ac plus b cube is equal to 3 into abc. A plus c into ac plus b cube is equal to 3abc. So this is the condition. So when we have to use this condition, if that one of the root is a square of the other root, one of the root is a square of the other root, at that cases this condition we have to use. So children, these are the conditions what we have to apply in that next worksheet. Okay, so before starting that worksheet, first you have to go through that all these conditions. So if you learn these conditions properly, then only we have an idea, we will get that idea where we can use these conditions. Okay, so after this one, in the same concept we are having transformations. So transformations means nothing here, just we have to find that new quadratic equation. Okay, so at that cases also like this some conditions there, so no need to use the total formula, just by using that conditions we can write that new quadratic equation. So that concept we will discuss in that next video. Okay, thank you all.